All right, here we go. Question number 3 from our Precalculus, homework number 12 in MyLab Math. It says graph the curve whose parametric equations are given and show its orientation. Find the rectangular equation of the curve. And here they have given me my two parametric equations and my restriction on t. Now, what I'm going to do before I go to my scratch work is I'm going to sneak a peek at the answer choices to see what to expect. It appears that the graph could either be an ellipse with a horizontal major axis, an ellipse with a vertical major axis, whatever that is, a sideways parabola maybe, or a cosine curve. And so these are the choices. Now let's take our equations to our scratch work and figure out which one of these is correct. Okay, so over here in my scratch work, I've copied down my parametric equations as well as I've started listing the values that t could be. It said that t goes from 0 to 2 pi. And so I've just chosen the first few unit circle angles. And what we're going to do is plug in for t and calculate some ordered pairs. Now the best way to do that is with our Casio class whiz. So since these are radian angles, we need to make sure we're in radian mode. So in order to switch to radian mode, we're going to go shift and set up the angle unit set to radian. And it may be really hard to see in the video, but now there's a little R up there on the screen. We know we're in radian mode. So here we go. 7 cosine of 0 is going to be our first x coordinate, which is 7. And then 8 sine of 0 will be our first y coordinate, which is 0. And so now we can write that down in our scratch work, 7, 0. And that should be a point on the graph. Now what we could do, since we have answer choices to choose from, is we could go back and see if any of the graphs hit the point 7, 0. Because if only one of the graphs intersects this ordered pair, then that has to be the correct answer. But we're going to continue to calculate a few more points just for fun. 7 cosine of pi over 6. Now the class whiz is awesome in the fact that you can use the fraction with the pi symbol. You see, you can input that just the way it looks, and it's going to give you the answer in simplest radical form. It gives you the exact value. Not all calculators do that. But remember, I'm going to have to plot this point. So I would rather have a decimal approximation. We can get that super easy by hitting the SD button. And that's going to be about 6.1 rounded. And then back to our Casio. And we want to do 8 sine of the same angle. Pi over 6. And that is going to be 4. And so that gives us another point on the graph, 6.1 comma 4. And then I'm going to go ahead and repeat this process and skip forward in the video. Okay, so not boring you with a bunch of calculator work, skipping ahead, I've calculated all of the ordered pairs from 0 to pi over 2. Now let's actually take those points to the XY coordinate system and let's see if we can get an idea of what we've got. So the first ordered pair 7, 0, that is an x-intercept. And the last ordered pair 0, 8 is a y-intercept. And then estimating the points in the middle, let's see, 6.1 up at 4, 4.9 up at 5.7, 3.5, 6.9, we can see what we have here is, well, it looks like the beginnings of an ellipse. And so this is probably going to be symmetric. So if we wanted to, we could copy and paste to the other side. 1, 2, 3, 4, 5, 6, 7. So this is probably going to curve on down like so. Yeah, something like that. And then we can see that the length of this axis from side to side is going to be 14. And then the length of the other axis is going to be 16. 8 and 8 is 16. So this is going to be an ellipse with a vertical major axis. So let's go back and see how we did. Okay, so the answer choice with a vertical major axis is answer choice B. Yay, and we got it. Awesome. I think maybe what I'd like to do is look at an alternate method rather than plotting a hell of a lot of points. Let's see if we can go back and figure this out algebraically. All right, here we go. Let's do some math magic. This is actually going to answer the second part of the MyLab math question, but we're going to see if we can actually get the first answer, the graph, as well from this answer. So what I notice is that I do have a cosine t and a sine t. What I would like to do is do a little manipulation to isolate those trig functions. So for the first equation, I'm going to divide both sides by 7, giving me cosine t equals x over 7. And for the other equation, dividing both sides by 8 is going to give me sine t equals y over 8. Now, from our trigonometry, we know that we have an equation, a Pythagorean identity, that says sine squared theta plus cosine squared theta equal to 1. And then I want to substitute. Okay, so let me rewrite this real quick. Sine squared theta is also sine theta squared. Cosine squared theta, cosine theta squared, and then I'm going to substitute. So sine of theta in this case is y over 8. That'll be quantity squared. Cosine theta in this case is x over 7, again quantity squared, equal to 1. And then if I switch the order, let's switch the order here. So we have x squared over 49. Did you see what I did? I went ahead and squared the fraction. Plus y squared over 64 equal to 1. Now do you notice where I'm at? This is now the standard form of the equation of an ellipse, right? Because the ellipse has the plus in between the two fractions. And we know that the bigger denominator, that is the a squared, and so the other one is the b squared. And then we can go back to our information sheet, knowing that the larger denominator is under the y, that will indicate whether our major axis is a vertical major axis or a horizontal major axis. So all of this work here algebraically would have also led us to the correct graph. But now what we want to do is go back to MyLab Math and see if this is the correct rectangular form of the equation. And back to our MyLab Math, determine the rectangular equation of the curve. So the first three answer choices do not match what I got. Oh, there it is. Answer choice D had the 64 under the y squared and the 49 under the x squared. And we're good. So that's going to do it for this particular problem. If you have any questions or comments about anything covered in this video, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.